Hey everybody, welcome to video lecture 2 of our video lecture series on Introduction to Algebra. This lecture we're going to cover solving equations. Last time we covered looking at signed numbers and then looking at solving, or shall I say, moving expressions around and combining like terms. This time we're going to use those techniques here to help us solve equations. Now, when solving equations, one of the most important principles we have, and we have a few very important principles, is the addition principle. And what the addition principle says, whenever you have an equation, think about that equal sign as being a balance. Well, in order to maintain balance on each side of the equation, we're going to have to add each side by the same number, or this works with subtraction as well. So if you notice the example we have here in example 1, x plus 7 equals 35. Well, since 7 is being added to x on the left-hand side of the equation, what we can do is subtract both sides by 7 so that we can get x completely by itself. And in doing so, we see here that x plus 7 equals 35. When we subtract 7 from both sides, we get x equals 28. Now, what's nice about solving equations is that you get to check your own work. And you can always make sure that your solution does maintain balance. And if we take our solution of x and replace it with 28 and ask ourselves the question, does 28 plus 7 actually equal 35? Excuse me. Let's get rid of that. If 28 plus 7 does in fact equal 35, then we know we're in good shape. And here, since 28 plus 7 gives us 35, both sides maintain equality. While this may seem pretty non-necessary in this step, as these equations get a little bit more rigorous, checking the work is going to be really helpful in making sure that you've provided an accurate solution. Now, looking at example 2, if we have 5 plus x minus 19 equals 60, what we can keep in mind and why we cared about doing this in the first place is combining like terms. If you notice, 5 and negative 19 are like terms, and 5 minus 19 is negative 14. So this same equation can be expressed more concisely as x minus 14 equals 60. Now, notice that 14 is being subtracted from both sides of the equation. So if we add 14 back to both sides, we can remove that 14 from the left-hand side of the equation and move it over to the right, leaving us with an answer of x equals 74. And here, checking something like this is as simple as just plugging it back in and thinking about it manually. Well, 74 minus 14 does in fact give us 60, so we know we've solved this one right. The next principle that's a really important principle for solving equations is the multiplication principle. And just like the addition principle, it uses a concept of balance, which says if we multiply both sides of an equation by the same quantity, or we divide both sides of the equation by the same quantity, we end up with balance. So if we look at the first example, 3x equals 15, notice that's really the same thing as saying 3 times x equals 15. Just like we saw in the last handout, anytime there's no operation between a number and a variable, it's always assumed to be multiplication. So it's really easy to divide our 3 here. This one's nice. And notice here, we divide both sides by 3 since 3 was being multiplied to x. The way I've always remembered this is try to undo what's being done to the variable. That way you can isolate it and ultimately get it by itself. And if we check, 3 times 5 does indeed give us 15, so that looks good. Now, the multiplication principle, one thing I want you to be real careful about with this principle is when you're dealing with signed numbers. Let's look at the same problem, but let's imagine that it was negative 3x equals 15. You know, being the fact that we're humans, we have a tendency to do things pretty quickly. And it's very easy to look at this problem and say, oh, okay, we've got to add 3 to both sides. You can see that's going to give us the wrong answer because if we say negative 3 plus 3, 15 plus 3 is 18. No way is negative 3 times 18 giving us 15. So be careful here. The sign just tells us that we need to divide by a negative number in this case. So here, negative 3 is being multiplied to x. So we're going to divide by that quantity on both sides of the equation, leaving us with x equals -5. So signs absolutely matter. And when it comes to multiplication principle, they're just going to come along for the ride. Now, here's an interesting one as well. If you look at example 2, and I'm just going to get rid of this here, guys, excuse me. If you look at example 2, notice that we have a fraction being multiplied to the variable. Now, we learned in other classes that any fraction multiplied by its reciprocal is equal to 1. Well, let's think about that. Let's say we have -2/3 times x equals 24. Well, what we're really needing to do is take this quantity that's being multiplied to the variable and divide by it. But you can see this is a lot of work. Oops, excuse me, guys. This is a lot of work for our calculators. And this is where we could end up making some potential errors in the way we set this up. All right. So if we look here, notice a lot of work. So there's got to be an easier way. In fact, there is. We know that dividing by a fraction is the same thing as multiplying by its reciprocal. So instead of using this technique, we can use the technique that you see below. And we can really do this for any fractions that are being multiplied to the variable. So looking at this a little further, if we have -2/3 times x equals 24, we can multiply both of those sides by the reciprocal, which happens to be -3/2. And by doing that, notice that -3/2 times -2/3, you can see that any fraction multiplied by its reciprocal leaves us with just 1. So we have here 1x equals, excuse me as I make my way down here, 24 times -3/2. And we just have to work that out in the calculator, giving us -36. So here's a good one to check, and why checking is really important as we move along, especially when we look at the next examples. If we're going to go ahead and check this, we want to make sure we substitute back into the original equation. Nowhere along the lines do we want to substitute back into one of our reworked parts of that equation. So here, if we take -2/3 times -36, we're going to get negative times negative is going to give us a positive, and 2 times 36 is, oops, excuse me, guys. 2 times 36 is 72, divided by 3 does in fact give us a positive 24. So we know we've done this right. So take the time to check, especially as these get more rigorous. It's really important. All right, moving on. We're going to start talking about using both of these techniques in combination to look at many different types of equations to solve. We're going to work with literal equations, which just simply means equations that contain, let's say, one variable, and that variable does not have an exponent on it. Well, the first thing that we would have to do in any case is distribute. So if we see that we have parentheses, we have to go ahead and distribute to get rid of those parentheses. And that's important because if we're going to add or subtract, combine these like terms, we have to know what these terms actually are and see how they're scaled up if, in fact, we're working with a distributive property. Once we do that, the next step is to combine your like terms. For instance, combine all your x terms and all your constants, and then we'll be able to go ahead and move our constant terms to one side of the equation and our terms involving the variable to the other. And that's what brings us to the second step. Once we distribute and remove any parentheses, the next step is to combine like terms and now move those terms from one side of the equation to the other so that we have the same types of terms on each. So we do that by using the addition principle first. That's really the easiest way to do this. So notice here, what we want to do is take all of our constant terms and move them. Let's use a standard procedure here. There's definite flexibility, but it's nice to have a standard in place, especially if you haven't done this for a while. We're going to move all of our variable terms to the left-hand side of the equation, and all of our constant terms, our numbers themselves, to the right-hand side of the equation. And that's the standard I'm going to be using for the rest of this video lecture. If you're more advanced here and you want to move to either side of the equation, that's certainly up to you, and that will work just fine. Once we've got the variable terms on the left-hand side of the equation and the constant terms on the right-hand side of the equation, this is where we can use that multiplication principle last. And we can multiply or divide, divide by the number that's being multiplied to the variable on that left-hand side of the equation. That way, we can go ahead and get that variable completely isolated, and we want to get it completely by itself. So remember, when you're using the multiplication principle, if the number in front of the variable is negative, you have to divide by that negative value. And also remember that if you have a fraction being multiplied to the variable, go ahead and multiply both sides by the reciprocal. So here are some examples. And what I'm going to do is take these examples and break them down step by step and talk it through. If you feel comfortable with these examples, you can move on to beginning to work through the examples that you have here on the next slides. Okay, so our first example is 2y minus 3 equals 11. So using the rules that we just discussed, notice that there's no need to combine like terms. We have two non-like terms on the left-hand side of the equation and 11 on the other. So what we can do now is think about using the addition principle to get the variable terms on the left-hand side of the equation and the numerical terms on the right. And in doing so, notice that the only thing we really have to do is get this 3 that's subtracted on the left-hand side of the equation over to the right-hand side. It's being subtracted, so we'll add it to both sides to undo that subtraction. And that's going to leave us with 2y equals 11 plus 3, which is 14. Notice this is why we use the multiplication principle last. Who wants to have to divide everything by 2 in that original equation? Now notice 2 is being multiplied to y, so what we're going to do is divide both sides by 2 to get that y completely isolated by itself. Y equals 7. Now I won't do this for every problem as we work through, but here's where it becomes really important to check your work. It's not necessarily the case that we can just see the answer like in the ones before. So notice we had 2 times y, which we just solved to be 7, minus 3 equals 11. Now, if we try this out, 2 times 7 is 14. 14 minus 3 is 11, which means, this is really a question that we're asking ourselves, and now we see it's true, 11 does equal 11, so our solution for this equation is absolutely correct. All right, now let's take a look at another example. Just bear with me for a second as I clean this up. And as we move on to one of the other examples. So now let's take a look at this next example, example 2. Here we have 5x plus 7 equals negative 3x minus 49. Now this one could be more challenging for someone who hasn't worked with algebra for a while, or if it's just something that's not been your favorite thing to do, because these are where you start to look at these and say, oh man, how do I go about this? Well, just remember the rules. First thing first, combine like terms if we can. And notice these are not like terms, and on the left are not like terms, and there are unlike terms on the right. So we're ready to use the addition principle. What we want to do is get all of our x terms to the left-hand side of the equation, all of our constant terms to the right. So what we're going to do is, let's think about it. If we want to get all the x terms to the left, the only thing keeping us from doing that is this negative 3x on the right-hand side of the equation. Since it's negative, it's being subtracted. Well, what undoes subtraction is addition. So if we add 3x to both sides of the equation, we can bring that 3x term over to the left-hand side. Now, these guys cancel. Notice anytime we add opposites, it gives us 0. And now we want to write down our new equation so that we can continue to solve. 5x plus 3x is 8x, and we still have a plus 7, so that has to go along for the ride. Our equal sign separates the left and right-hand side of the equation. And now we have negative 49 on the right-hand side. So next step, let's go ahead and get this number term to the right-hand side of the equation. And notice that it's being added. So what undoes addition is subtraction. So we're going to subtract 7 from both sides of the equation, leaving us with 8x equals negative 49 minus 7. And, you know, I mentioned this last class. This is where you're really focusing on algebra, not arithmetic. It's really easy to make mistakes. So don't hesitate to get out your your calculator to make sure that you can validate that you've applied these signs correctly. This is going to give us negative 56. And our last step is getting that 8 over to the other side. We want to get that x completely isolated. So what we're going to do is divide both sides by 8, since 8 was being multiplied by x. And that's going to leave us with x equals negative 7. And let's compare that to the answer we see typed. There it is. And notice, really important, check that work, especially for one like this, because it takes a little bit more time and care, and it is possible to make a sign error. And those are the things that we really want to be watchful of. All right, now it's your turn. Try to apply these rules that we just discussed. And what I ask you to do is pause the video here for a moment and try numbers 1 through 4, and then we'll review them together. Okay, let's take a look at these values together. So let's start with 1. What you should have gotten for 1 is, in this case, negative 4. And excuse me, we should actually be getting positive 4 on this one. So let's take a look at this one together. Why positive 4? Because 7 is being subtracted from A. So we're going to add 7 to both sides of the equation. And negative 3 plus 7 does in fact give us a positive 4. Now looking at number 2, if we have negative 6 times x equals 42, what's keeping that x from being by itself? Well, it's that negative 6. And since it's being multiplied to x, we're going to go ahead and divide both sides by our negative 6, canceling this on the left-hand side and leaving us with an answer of negative 7. Next one, if you notice here, we've got a situation where we have variable terms and a constant term on the left, and we have a constant on the right. So let's bring those constant terms over to the right-hand side of the equation by adding the fact that our 5 is subtracted. We'll add that 5 to both sides. And notice this is going to leave us with, and I'm just going to push this right over here to give a little more space, 2x, we lost that negative 5 by adding it, is equal to 17 plus 5, which is 22. We'll go ahead and divide both sides by 2, and that's going to leave us with a value of x equals 11 for this next example. All right, one more to go before example 6. So here we have 3c plus 13 equals negative 47. I'm going to give myself some space here, just because I know I'm going to run onto the end of the slide, and I don't want to do that to you guys. So we have 3c plus 13 equals negative 47. Now, let me go ahead and subtract 13 to bring that number term over to the right-hand side of the equation, leaving us with 3c equals negative 47 minus 13, which is negative 60. Last step, go ahead and divide by 3, and that's going to leave us with c equals negative 20. And that's our final answer here. Remember, you should be checking these as you go along so that you know that they're all valid. And that's the beauty of this. Seeing something like this on a quiz or an exam is nice, the fact that you can actually check your own work and know that your answer is correct before moving on to the next. Okay, now I'd like you to pause the video and try example 6. These are our last 3 examples in this video lecture series. All right, I think we're ready to get started. So let's see how you did. What you should have gotten for number 1 is a equals 8. For number 2, y equals negative 14. Oops, excuse me, guys. Sorry about that. And lastly, this one's a little different, and this one tends to give a big challenge because it's the first time we've looked at one like this. In this case, x equals 0. So let's go ahead and take a look at these results. And I'll tell you what, one can be more challenging because there's no coefficient in front of the a. But remember, a is just the same thing as 1a. So what I'm going to do here, just like in the examples before, is bring the numerical terms over to the right-hand side of the equation. Bye-bye. And now what we have is 2a equals 1a plus 8. Notice our last step here, we're going to go ahead and subtract a, or if it makes it easier, you can write out that coefficient of 1 from both sides. And that cancels it on the right-hand side of the equation and leaves us with 2a minus 1a gives us 1a, or just a, equals 8. Some people like to be very thorough and actually write 1a equals 8. And honestly, that's fine for me because I can understand why you'd want to do that, just to show that that's what coefficient you have in front of your variable. All right, so let's take a look at the next one. I'm just going to give myself a little bit more space here and clean this up so you guys can see this one. Now notice in this case, this is the first time we actually have to go ahead and distribute before we can go ahead and solve the problem. So if I bring this up here, we have negative 3 times y plus 4. So let's just distribute this over here on the left-hand side of this slide. This is going to leave us with negative 12y minus, oh, excuse me, you see my mistake there? Silly me, that's the next part. Negative 3 times y is negative 3y, and then negative 3 times positive 4 is going to give us minus 12. So we can clean up the left-hand side of the equation by writing negative 3y minus 12 equals 30. Now this is a lot easier to solve, and we'll go ahead and do it. We'll add 12 to both sides of the equation, left and right, to bring it over to the right-hand side. And what we've now got is negative 3y equals 30 plus 12, which is 42. Last step, divide both sides, be careful here, by negative 3. And that's going to leave us with y equals negative 14. And that's how we get our answer here. All right, last one of this video lecture. Let's just clean this up and make a little space. All right, let's see how we get x equals 0. I'm going to start here with number 3 by distributing those parentheses first. And 5 times x minus 2 is going to give us 5x minus 10. And we still have this minus 3x on the left-hand side of the equation. And this is going to equal 4x minus 10. Now what we want to do to continue to work through this problem is we want to combine our like terms. And notice we have like terms on the left-hand side of the equation. So really for the first time we've done this. So bringing this over here, 5x minus 3x gives us 2x. And we still have this minus 10 on the left-hand side of the equation. So 2x minus 10 equals, and excuse me, I'm going to give myself a little bit more space here. Notice we're bringing this right up here. We have 5x minus 3x, that's 2x, minus 10 equals, and this is going to look a little funky, 4x minus 10. Some people stop here and say, ooh, something's weird. And that's rightly so, because this is interesting. Notice what I'm going to do is just continue to follow the rules. I'm going to bring those number terms over to the right-hand side of the equation by adding 10 to both sides. And notice that in this case, excuse me, it cancels on both sides. And we're left with 2x equals 4x. Now, I often see people at this stage, excuse my shaky writing here, I often see people at this stage say, oh, there's no solution. But notice that's not actually the case here. Excuse me, I'm just trying to clean this up for you guys here. My eraser doesn't seem to want to work. There we go. I'm just going to write this one again. Okay, scratch that. So what we have here is 2x equals 4x. Now this is odd, right? And a lot of people will put no solution here. And the problem with that, oh, this is my 2x here. Sorry, guys. Okay. The problem with that is that it's not enough to say no solution because there is a solution. So what I'm going to do is subtract 4x from both sides of the equation. And notice that 2x minus 4x gives us 2x. And 4x minus 4x gives us 0. I brought those number terms, or excuse me, variable terms to the left-hand side of the equation. If we divide both sides by 2, we can see that x is actually equal to 0 over 2, which is equivalent to 0. So the answer for number 3 is x equals 0. Excuse my lack of technology here, not sure what happened on that computer there. You can stop at this point. Some people recognize this as enough. But there is a solution. Remember, x equals 0 is a solution, and it makes sense because the only number you could multiply by 2 and multiply by 4 and get the same quantity would happen to be 0. All right, so that's it for video lecture 2. This is going to take you through the rest of the homework worksheet, solving equations. So let's just go take a peek here. Discard those. And if we take a peek in Canvas real quick, what you'll notice is we've now solved, or we've looked at everything that you need to solve part 2 of this homework worksheet. Remember that you're asked to complete part 1 for Friday of week 8, and then you can complete part 2 of this worksheet and actually submit the completed packet on Friday of week 9, and you can certainly come in with any questions. As you work through your packet, do keep in mind that as you work through these equations, you can check your work and make sure that your answers are valid right here. So do check your work and make sure that your solutions are accurate. And if there's any that you want to review together, you're more than welcome to come into class and ask some questions. All right, so I do hope this lecture was helpful. I hope you are aware of everything you need to do to be prepared for Friday of week 9, including the in-class material that's covered. And I hope that you found this to be helpful. Don't forget where you can find this stuff, week 7 alternate assignments. All right, guys, have a great week and happy studying.